Alright, hello everyone. Welcome back. I'm Teacher Chi Yew. Thank you very much for coming over. And I'll be going through the AMC Middle Primary 2019 paper, past year paper, questions 26 to question 30. So hopefully all of you guys have attempted the paper and you guys are ready to check out your answers for the worked solutions. Now, without further ado, let us begin on question 26. Now, at my local greengrocer, you take a ticket from the machine and wait until your number is called. The row of tickets goes from 000 up to 999. When I was there last week with my neighbor, we took 2 tickets in a row and our 2 numbers added to 777. Now the question is, what was the next ticket number after ours? So in this case over here, last week, he and his neighbor has taken 2 tickets each and both numbers add up to 777. Our goal is to try and find the next ticket number after his and his neighbors. Now in this case over here, we can actually try and simplify this problem by using a little bit of algebra. So in this case, we can let n represent the smaller ticket number taken. In this case, what will be the larger ticket number taken? In this case, it will just be n plus 1. But remember this, the sum of both tickets adds up to 777. So we can see that n plus 1 will just be equal to 777. So in this case, we have 2n plus 1 equal to 777. Now subtracting 1 from both sides, we are going to obtain 2n equal to 776. And dividing by 2, we are going to get n equal to 388. So in this case, the person, himself, has taken 388. And his neighbor has taken 389. Now, in this case, that will mean that the next ticket number would be 390. Alright, so in this case over here, I hope everyone is able to understand that using a little bit of algebra and manipulating a bit of the equations will benefit us greatly, especially when trying to work on these kind of questions. So hopefully everyone is able to understand this. And without further ado, let's move on to question 27. Now, what's question 27 about? There are 390 children at a summer camp. 1/3 the number of girls is equal to 1/2 the number of boys. Now the question is, how many girls are there? So in this case over here, this looks like a very typical model question. So we are going to take the model approach. Firstly, we know that 1/3 of girls is equal to 1/2 of the boys. So in this case, we draw our model. So I'll let girls be represented by G and boys be represented by B. So if there's 1 unit of girls, and this will be equal to 1/2 of the boys. So in this case, for girls, we only have 1/3. So we need 2 more units in this case. And what about for the boys over here? The boys, we have 1 unit, but it's only 1/2 of the boys. So we need to add 1 more unit for the boys as well. In this case over here, what's the total? We know that the total is 390. And then we can apply our unitary method now. We notice that 5 units is equal to 390. What about 1 unit? 1 unit would be 390 divided by 5, which will be 78. So what are we looking out for? In this case over here, remember, we are asked how many girls are there. In this case over here, there are 3 units. Girls form up 3 units out of all these 5 units over here. So what we need to look out for will be 3 units. And that will be 78 times 3, which will give us an answer of 234. And hence, there are 234 girls in the summer camp. Hopefully everyone is able to understand this. It's a more straightforward question as compared to many others because it can be easily solved using the model method. But more importantly, we need to understand the relationship that 1/3 of the girls is 1/2 of the boys. We need to be able to interpret this sentence and be able to draw out the model accurately. So hopefully everyone is able to understand question 27. Now let us move on to question 28. Now for question 28, the question asks us, how many of the numbers from 100 to 999 have exactly 10 digit? Well, some of you guys might be asking, hey, maybe you can just list out all the numbers. Well, let's start off with 100. 100 has 2 zeros, so it's not counted. 101, oh yes, there's only 1 0. 102, there's also another 0, and so on and so forth. Well, I would personally say that it's a little bit difficult if we try to do that because listing out is going to be very tedious. And definitely from 100 to 999 is going to be worse. So what I would personally suggest is that we break up this problem. Instead of considering 100 to 999, we can try and consider 100 to 199 first. For the simple reason being, the number of numbers that have exactly 10 digit from 100 to 199 is going to be the same as the numbers having exactly 10 digit from 200 to 299, 300 to 399, 400 to 499, and so on and so forth, all the way to 999. So all we need to do is to find these numbers over here for 100 to 199, and then we just need to multiply by 9 in order to get our final answer. Now, how do we go about doing this? Well, we can look at 100 itself first. 100. So we have no single zero for here, so we do not include this. And then afterwards, we look at the next few numbers. 101, 102, 103, all the way to say 109. 101 to 109. How many numbers with exactly 10 digit in this case? Well, we have 101 is counted, 102 is counted. In fact, all the numbers over here are counted. So there are 9 single zeros over here. Single zero numbers, alright? Now, what's next? Well, we can take a look at the next last set of numbers, which is 110 to 199. How many numbers with exactly 10 digit? Well, in this case over here, it's pretty straightforward as well. We can take a look at 110, 120, 130, 140, all the way to 190. We notice that in the same way, there are also 9 single zero numbers over here. So, in order to conclude this, we notice that from 100 to 199, there are a total of 18 single zero numbers. Right? Now in this case, since there are 18 over here, all we really need to do, we remember that there are 9 sets over here. We have 100 to 199, 200 to 299, 300 to 399, and so on and so forth. So in this case, we have a total of 9 sets. So the total numbers we need to multiply by 9. 9 multiplied by 18, which will end up to 162. So there are 162 numbers with exactly 1 0 digit. So I hope everyone is able to understand when we are faced with such difficult problems, it makes sense for us to try to break the problem down, look at parts, and try to identify different patterns. Alright, so I hope it's pretty clear. Now, let us move on to the next question, which is question 29. So let's take a look at this question over here. Now, a tower is built from exactly 2019 equal rods. Starting with 3 rods as a triangular base, more rods are added to form a regular octahedron. With this base as shown one of its faces. The top face is then the base of the next octahedron. So the figures show the construction of the first 3 octahedra. How many octahedra are in the tower when it's finished? So in this case over here, we notice that octahedra is something like this. And then if we are to actually count it, how many rods did we use up over here actually? There are a total of 12 rods over here. Alright, now in this case over here, since there are 12 rods over here, we notice that we need 3 rods to form the base. And then afterwards, when we add 9 to it, we actually form a single octahedra. And then we notice that in the same fashion, if we are to add 9 again, we're going to form another octahedra. We're going to keep adding 9. Why? Because when we form an octahedra, there is actually the base. It actually also forms the base of the next incoming octahedra. So we save on 3 rods. We do not need to keep on adding 12 rods over here. So what would be the formula in this case? Alright, so in the same fashion, we are going to let algebra help us out. So in this case, we can let n represent the number of octahedra built. So suppose, let us take a look at the pattern over here. If I would like to build just one octahedra, I will need 3 as the base first, and then add a 9. But if I need to build 2 octahedra, I need 3 as the base first. Alright, so 3, and then we add 9 for 1 octahedra. So this one is n equal 1. What about n equal 2? We need 3 as the base, and then we add 9 again to form 1 octahedra. And all we need to do is to top up another 9 for 2 octahedra. Now you can see this pattern going on in this fashion. For n equal to 3, that will be the idea as well. 3 as the base, add 9 to form the first octahedra, add 9 more to form the second octahedra, and add the last 9 for the third octahedra. So you can kind of see the formula now. In this case over here, it will just be 3 plus 9n equal to 2019, because we have used 9 rods in this case. Now subtracting a 3 from both sides, we are going to obtain 9n equal to 2016. And then lastly, we are going to divide by 9. And then we are going to obtain 224. 2016 divided by 9 is going to give us 224. So, how many octahedra are there in the tower? There will be 224 octahedra in the tower. So for such pattern questions, it will be much simpler if you try to identify the pattern. Alright, we know that the base, the top of the octahedra will form the base for the new octahedra. So we are actually getting a discounted amount. every time we try and build, we try to add on to another octahedra, and so on and so forth. So hopefully you guys are able to understand this particular pattern and be able to apply when a similar question like this comes up. Now, let's move on to the last question for this video. So let's take a look on what this question is about. John is 1 year older than his wife Mary. They have 3 children whose ages are 2 years apart. So they have 3 children, each of them has ages of 2 years apart. Now the product of John and Mary's ages is less than 2019. The product of the 3 children's ages is also less than 2019. But what about next year? Next year, both these products will be greater than 2020. So this year, what is the sum of all 5 ages? Now, so this one would be very closely related to our perfect squares and perfect cube numbers lesson. So in this case over here, since calculators are allowed, we are going to make full use of the calculators for this competition. So it will make sense for us to try and get a good estimate of what would be the age of Mary and what would be the age of John, what would be the age of their 3 children using the numbers over here. So now firstly, let's take a look at John and Mary. Well, their ages are roughly equal. So let's take a look at the square root of 2019 to try and get a good estimate. Now the square root of 2019 is roughly 44.9 using our calculators. So this one will give us a hint that we can actually estimate that Mary's age will be roughly 44. And then in this case over here, John's age will be roughly 45. Now, so in this case over here, we can't just only estimate, but we also have to check whether the conditions are satisfied. Now, in this case over here, we need to check whether 44 times 45 is lesser than 2019 or not. Well, let's take a quick look over here. 44 times 45 itself will just be equal to 1980, which is less than 2019. But what about 1 year later? Their products will be greater than 2020. So let's take a look. The next year, Mary will be 45 and John will be 46. So it's 45 times 46. Now this one is going to give us 2070, which is clearly greater than 2020. So these 2 numbers are the ages of John and Mary. Now what about the 3 children? Well, this time around we have 3 children, so we are going to expect somewhere along the lines of cube root. But before that, we are going to let n, to simplify things, let n represent the middle child's age. So in this case over here, let's take a look at cube root of 2019. Now the cube root of 2019 is roughly 12.6. So in this case over here, we can roughly estimate, hey, it might be possible that n might be equal to 12. In this case, the youngest child will have an age of 10, the oldest child will have the age of 14. So this is something that we can make a good estimate on. We can give it a check as well. So let's take a look. 10 times 12 times 14. How much will it be? It will be 1680, which is less than 2019. Alright, what's next? We also have to check the next year condition, which will be 11 times 13 times 15. In this case over here, it will be equal to 2145, which is greater than 2020. So we are for sure that the ages of the 3 children is 10, 12, and 14. So is that it? No, right? We still need to find the sum of all the ages. Now in this case over here, the sum will just be 10 plus 12 plus 14 plus 44 plus 45. And that will give us a final answer of 125. Alright, so with that will be our final answer, and I hope everyone is able to understand a little bit better about square roots and cube roots functions in this question over here. And I hope you guys are able to apply this when something similar goes out. So, of course, if you guys have any questions for question 1 to question 25, feel free to contact me in the WhatsApp, and I'll be able to get back to you as soon as possible. But with that, we'll end this. That's it from my side over here. Do keep a lookout for the next set of papers in order to prepare yourself better for the AMC. Right, with that, thank you very much and goodbye.